In this lesson, we're going to talk about the historical development of the atomic theory. And the idea that matter is made up of atoms started with the Greeks. Uh, Democritus in 460, who lived between 460 and 370 BC, proposed the idea known as atomism. And the basic idea is this: if you were to cut up matter into smaller and smaller and smaller pieces, eventually you get to a point when you can no longer cut it. So that smallest possible bit of matter is called atomos in Greek. Means not, and tomos means cut. And what's between the atoms? There's nothing. So you could say that the universe is made up of atoms and the void. Unfortunately, Democritus provided no supporting evidence for this idea. The philosophers are famous for being thinkers and not workers, so they did not do any experiments to validate their ideas. So this idea of atomism did not really flourish, uh, particularly because it's contrary to the beliefs of more influential philosophers of the time, Plato and Aristotle. Okay, so the idea of atoms was elevated to a scientific theory by John Dalton centuries later. Okay, and Dalton based on numerous experimental data, made the following assumptions. So these are his assumptions. These are the postulates of Dalton's theory. Using these assumptions, we can explain a lot of things. So he was able to explain a lot of experimental observations. Okay, so that's what a theory is. A theory is basically a collection of ideas upon which you base your explanations for a whole variety of stuff. Okay, so postulate number one, according to Dalton, matter is made up of indivisible particles called atoms. Postulate number two, all atoms of the same element have the same mass. Okay, so if you have an element, it's made up of only one kind of atom. All those atoms have the same mass. We now know, we now know that atoms of an element can have different masses. We've talked about isotopes before. Atoms of different elements have different masses. So these are the assumptions of Dalton, that elements are differentiated from each other by their mass. We now know they're differentiated from each other by their number of protons in their nucleus. Okay. Dalton also assumed that in compounds, atoms of different elements are combined in a fixed whole number ratio. In other words, there is a formula for a compound. If you were to do a count-to-count ratio of the different elements, the count-to-count ratio is a well-defined whole number ratio. And postulate number five says that if there are changes observed in matter, then during those changes, atoms are neither created nor destroyed. They just rearrange. They just change the way they are organized.